Hey, good morning, everyone. It's great to have you here. My name is Tingyi Li, and I'm an enterprise solutions architect from Amazon Web Services. I'm based in Stockholm, and I work with major Nordics enterprises, especially from manufacturing industry. So actually, Gothenburg is one of the cities I come very often. So today, I'm here to talk with you about enterprise adoption of large language model-based multi-agent systems. So first of all, let me ask around a bit. So how many of you here maybe have tested agent or created your own agent or maybe deployed your agent in production before? OK, I see a lot. Oh, actually, I see maybe almost 50% of you. OK, that's perfect. So OK, I'm going to need my water. So if my voice starts to glitch in the middle, it's not a technical problem. It's just that I'm under the weather. So forgive me. And pretend it's a dramatic pause effect. Thank you. So a typical journey that we see many companies are now following when they want to start their very first agent is to start something small and focused by tackling some maybe internal productivity use cases. Like you can see here on the screen, like an HR bot for vacation and sick leave time management. And now, as over time, you maybe see some increasing adoption, and then you want to scale it better. So you can add some more functionalities, like maybe attach a knowledge base of your HR policies to answer your employees' questions. And then you want to make it maybe self-service. Then you can add some leave of absence actions so that your employees can just do everything and then maybe hand over within their teams, etc. So this is what we commonly see as, let's say, the building block of any agentic system, which we call a single agent. So essentially, you start with a prompt, right? Basically, your user prompts, user request, to define high-level objectives. And then at the center of the agent, there is a large language model at its core to reason and plan, so to break down the high-level objectives into subtasks and substacks. So that's the planning phase. And during the planning phase, you might also have some reflections and to kind of evaluate the effectiveness, so to make sure that steps are doing the right thing. At the same time, you have some tools to kind of expose your agent to external sources, maybe some third-party APIs, SaaS applications, so that it can perform certain tasks. At the same time, you have memories, so that you keep track of a history of conversation interactions, your user preferences, so that your conversations always stay relevant and related. And you can do a lot more, right? But if you take a single agent too far, so you add too many things in there, it leads to challenges. You're literally asking for problems. So first of all of the builders here, you might be really familiar, your codes will get really complicated, right? So you'll have more hallucinations, it's getting harder to debug and evaluate. At the same time, your agent also gets confused. For example, all these tools that you attach to the single agent, the large language model understands the tools based on its description. But let's say if you have hundreds of tools attached to your agent, it's very likely for it to call the wrong tools. Maybe there are some tools that are very similar, and then you call the wrong tools, and the whole process just collapses. And also, your agent will get slower and much more expensive. So why is that? First of all, your prompts get really long, right? And then, because you have to do a lot of extra checks on some edge cases, say, OK, if you run into this situation, please don't do this, or please remember to do this. So there's a lot of logics you have to implement there. At the same time, if the prompts gets longer, it's basically requiring you to find better model, to find the best model to keep up the performance. And typically, the better models means that they're way slower than maybe some slightly lightweight model for your particular use cases. So in this case, the best practice is simply to make sure that your single agent stays small and focused. So instead of have three different applications, one big giant agent, we wanted to break it down into three different applications, so that for each task, your user go to specific apps. But still, you see that single agent are siloed and limited. So first of all, you don't have a very good user experience. The experience is still splintered. It might work for your internal employee, but it's not for your customers, right? So you want to provide a constant and unified experience. At the same time, you might think, okay, I already have this small focus agent. I want to implement my multi-agent collaboration framework myself. But it can be very difficult because you have to also consider like security, maintenance, scalability, etc. And let alone, the most important question is still to be solved, is to automate this complex process. So that's why we have offered Amazon Bedrock multi-agent collaboration. So for those of you who have never heard of Amazon Bedrock, so it's a AWS fully managed service that offers you access to a bunch of foundation models with a set of capabilities to help you build generative AI applications in a secure and responsible manner, like knowledge base, like prompt flows, including agents. And multi-agent collaboration is one of the features from Amazon Bedrock agents that we launched last year. So essentially, with Amazon Bedrock agent, multi-agent, first of all, it's very easy for you to assemble a set of small focus agents with knowledge-based support tailored for specific tasks. At the same time, as you see from the screen, so you have a supervisor agent on top of all the small agents. And you don't have to code complex logic. You just need to connect all of them, give some instructions for each of them, and then the multi-agent collaboration will take care of the rest for you. At the same time, there is observability. It's not observability only about the whole process, but also you can look into like the observability within each sub-agent. And also, there's multi-hierarchy support. So basically, let's say if you have a really complex structure, the sub-agent can also manage their own agents. So basically, you see this is the hierarchical multi-agent pattern that we're talking about here. And this is also what's behind the scene for Amazon Bedrock. At the same time, there is built-in optimized router. So once you have the supervisor, it will automatically route so get the user request and intelligently route to the right sub-agents. And it's done by optimized router with intent classification built in there. And we're going to look at an example later. And also, when it comes to automation of the complex process, as we said, for example, here I have an example. Let's say you have a request, say, maybe make me some marketing campaign on a specific product. And here with a little description on the product. And here we have a supervisor agent, which is going to plan and orchestrate what exactly is needed to do this task. And then it will generate a plan automatically and then execute them across all these sub-agents it has. As you see here, we have a bunch of sub-agents like marketing, content creator, to help you execute it. And what's behind the scenes generally, so the high-level supervisor agent will plan like steps of list, and then it will go to each sub-agent, and the sub-agent will take the plan and also execute its own plan. And then that's why you see the substacks here. After it finishes the substacks, it will go back to the supervisor agent, and the supervisor agent will take the results back and then move forward. So you can see some parallelism, you can probably see some sequential steps, so it all depends on how, what makes the most sense for the task to be completed. So all these parts are pretty flexible and handled by Amazon Bedrock multi-agent. So here, if we take a look at a detailed example, let's say I have a startup advisor, which is the supervisor agent. And here I have a list of collaborators. So here I have lead market analyst, chief strategist, and also content writer. And also I have a creative director to give feedback on the content. And also I have a formatted report writer. And here I also define like a simple set key and get key as a working memory. So basically like a Lambda wrapper on top of DynamoDB, so that all these collaborators, all these sub-agents can interact with each other, retrieve information, share state effectively as they go. And then at the beginning, as we said, we need to give like a user request, right? So here's a list of like tasks for the supervisor agent to execute. So what exactly, in order to complete this task list, what are the steps that what are the plan that the supervisor agent can come up with? And then, as you see, once the supervisor come up with the plan, it gives orders to the collaborators, and then they start to maybe use various tools like web searches, getting some reports from website, maybe some internal knowledge-based lookups, etc. All these function keys to kind of start to execute it. At the same time, you see that content writer and content creator, the creative director, will start to collaborate. At step 6, right? Because it requires an iterative revision. So basically, the creative director will give feedback on the report draft from the content director, and then it will incorporate the feedbacks and then do the revision again, and then it forms a loop like this. And eventually, it will go to the formatted report writer, and where you can see the complete format in the report. So here I also have a little bit longer demo, but I don't think we have time to run through all of this. So essentially, I just want to show you, like, because this is one of the examples that we have. So if you're interested, we can also maybe show you the complete one later. So you can come to me. So essentially here, I just want to show you the demo where this is the initial prompt. So basically, you see here, you have like the task list defined. So it's very crucial that you define your prompts clear and concise, and in the right format. At the same time, you need to give some like niche edge cases advice. Say, okay, for this particular edge case, you have to do this. Please remember to evaluate in this way. So just give it a very good prompt to define your user request. And here is some of the execution steps that you can see. And this is the thinking process, like when it starts to planning and there's showing the reasoning process. So I will maybe move on. And here, this is the output of the produced campaign report. And here is the code. So I'm not going to play the whole thing, but just to show you. So essentially, see, this is how you define a supervisor, like a startup advisor. So you give its role, define its role, define its high-level objectives. What are the available tools? What are the, some instructions? What are the type of this supervisor agent, etc. Okay, so I'm going to move on. Another challenge that worth mentioning here is that sometimes there are some strict internal rules that on whether AI can take action or not, especially for high-stakes applications like legal or compliance cases, or let's say if you're from highly regulated industry like financial or pharmaceutical or defense, utilities, etc. So essentially, your AI is not allowed to take action without a human in loop. Sorry. So that's why we need to define this kind of cases. So basically, the simple answer is that you can have the agent responding to you the exact action that is supposed to take and require the human to give an explicit yes or no answer, say, like, before it proceeds, as you can see from the screen. So this is in your prompt of when you give the instruction to the agent. At the same time, there are some other special cases for handling, for example, escalation logic, which could be triggered by, let's say, you user specifically asked to speak to a human, or maybe there's user frustration detected in your conversation, then you want human to interfere. Or maybe it's just simply the agent is running out of capabilities to answer the user request. So this is to make your logic more complete. So this is also something you should consider when you design your use case in your prompt or in your entire application logic. At the same time, evaluation is very important, as the previous speaker have talked for her entire talk. So normally you will see, you'll have an evaluator agent within your multi-agent system. Just like, for example, the creative director in the previous example is an evaluator agent, you can say. So basically to prevent hallucinations and to ensure like the answer is helpful. So here I have two examples. Say, okay, the evaluator agent will base on the feedbacks, the outputs from the agent system, and then give corresponding feedbacks. And these feedbacks will be taken into the loops to make sure that there's revisions of the answers. Okay, so beyond Amazon Bedrock, there's also a bunch of either open source or other kind of agentic frameworks from different vendors. As you can see here, like popular ones like LangGraph, there's AutoGen from Microsoft, there's more like maybe research-wise. There's also Crew AI, which is very popular. So basically, all these frameworks aim at to provide you some sort of abstraction layer on top of this basic like GenAI apps function callings, like a language, maybe calling LLMs or incorporate databases easily, to kind of incorporate tools easily. But one thing to note is that you have to really understand that sometimes it provides additional layer of complexity because for all these frameworks, because it has to be generic, not just for your use cases. So it always incorporates some additional logic that maybe will slower your applications or make it more complex. So we see that people use all these frameworks together, like mix them all together with Amazon Bedrock or with some other frameworks. So make sure that you understand the underlying mechanisms or how it works behind the scene for those agents before you choose one. Because we have only talked about hierarchical agent, there's also other agentic patterns, right? So make sure you understand that before you choose. Otherwise, this could be like a common customer error that we see in production. And as your like the level of autonomy in your multi-agent collaboration application moves forward, so this is one of the source I got from LangChain. As you move towards to more complex automation and autonomy, here's a paper that is really interesting, which is published last month. Essentially, why do multi-agent systems fail? And it carried out like 160 tasks and 6 experts annotations and 14 different mistakes categories. And eventually, it summarized into these 3 common categories why multi-agent systems fail. So the first one is poor specification and system design failure. Basically, not sure how many of you know maybe chat dev. So it's basically like a research, like one of the cutting edge multi-agent systems to simulate a company for software development. And there's roles about like CPO, CIO, CEO. And one common mistake is that, for example, CPO, it's a product officer, right? But it misunderstood its role, and it constantly overstepped the role of a CEO because it assumes that it's CEO, as a lot of us do, right? So, so to make sure, like the information about your prompts, the definition, and also the second one is inter-agent misalignment. It's about communication. It's about how to align the key information while this execution of the loops within your multi-agent system. And the last one, of course, some task verification and system error, which is also very common. So basically, if you multi-agent loops gets really complex, sometimes it gets stuck there, or sometimes it just comes out of this. So last but not least, I want to mention evaluation again. So when it comes to productionize your multi-agent system, of course, first of all, is to keep things small and focused, right? And then you add like maybe a supervisor agent on top of it or some other kind of patterns on top of it. And then evaluate in production the cost and performance. So first of all, you need to choose agentic or multiple agentic frameworks to your use cases to make sure you benchmark them. For example, cost per run. So how much time it takes you, how much money it takes you to run this whole thing once in production. Maybe a development complexity. So you don't want to choose a framework that is overcomplicated for your use cases. Maybe maintenance as well. Maybe learning curve, like your team. Are they familiar with this kind of framework? And also maybe, of course, performance, like execution times, etc. And also installation complexity, like all these kind of things. Also to evaluate your multi-agent system. So for example, as our previous speaker mentioned, Ragas, so you can use that. There's also one that I link here. It's also one of the evaluation frameworks. There's also a bunch of other open source ones out there for you to help you to evaluate your LLM application. And last but not least is to prompt your agent really properly. Of course, it sounds a little bit on the paper, but I couldn't emphasize enough like how important this, like to really prompt it. Like this is a next-gen coding, basically. I would say that's basically everything I want to talk about today. So thank you for tolerating my voice. And if you are interested in knowing more, we can have a Q&A, or you can just reach out to me later. Yeah, thank you very much.
Thank you so much, Tingyi. What a clear walkthrough, really. We have time for one question from the audience. Is there anybody who would like to ask a question? Maybe there are raised hands, but I actually cannot see them. I do have one.
Yes, please.
I wanted to ask you, because you did emphasize human oversight, especially in confirmations and escalations in some points. Do you think we're close to standardize some kind of agent governance, or is it still not standardized?
I would say there's definitely some standardized one. Basically, when we say like there's governance framework, we try to standardize like a template, maybe with a few pillars. Say, okay, these are the few metrics that you can kind of use to evaluate these things. But it will be generic, so it won't be for your particular business. So you can, for example, if you want to evaluate, you can start somewhere with like the frameworks or like repos that you have, and then you add additional metrics on top of that. So we do have like some governance framework like that already.
That sounds fantastic. Again, I don't know if you can be available for people that might want to ask you questions afterwards, but I would say otherwise we are ready for the break. Thank you so much again, please.
Thank you very much.
Receive some flowers from all of us at Gaia.